Hi, I'm Carsten Schreiter from Product Marketing here at Semikron Danfoss, and I'm talking about the misbeliefs that we hear all the time when we talk about silicon carbide in motor drive applications. Today, the cost for silicon carbide in motor drive is too high and never pays back. This statement is actually not true, and I will tell you why. True is that silicon carbide costs more than silicon, and even though volumes go up or wafer sizes increase, that will remain. What makes the statement wrong is that the cost of silicon and silicon carbide are often compared on parts level, and that leads to wrong conclusions. I explained this for an active front-end application in another video. Here we will look at another typical motor drive application, a pump drive, which is by nature running in partial load for most of the time. We did the comparison here at 5 volt per nanosecond voltage rise time and 5 kHz carrier frequency, so rather slow. We calculated the losses in various load points and accumulated them over a typical operation pattern, and what came out is that the cost adder for silicon carbide could be compensated by the energy cost savings in just 1 year of operation. From the second year on, the silicon carbide solution even would save money. On top of that, with similar boundaries for the junction temperature, for silicon carbide the heat sink volume could be reduced by 70%, or alternatively, the power could be increased by 25% within the same thermal design. That means designers have now the option to reduce the drive size with the chain of benefits that follows, or they could use the same thermal design for more electrical frames, and by that reduce the design effort, the BOM cost, the parts logistics cost, test effort, and many other things. So it's pretty obvious from this example also that if the comparison is done in the correct way, considering cost and benefits on application level, then in many cases you would find that not silicon carbide is the expensive solution, but silicon. If you think now, that sounds good, I want to try it out, then have a look at our latest pin-compatible SiC topologies in mini-skip and semi-top E. We created those with motor drive applications in mind, and to make it really easy to swap to silicon carbide. Get in touch with us to learn more and to get into a deeper discussion.